Yep. Hi, everyone. Good to see you here. So I think the body of work that we're all involved in is creating this thing called cryptographic truth. Cryptographic truth, in my view, is part of the big tradition of truth operating society in general. The first truth was religious truth and mythical truth. The next was scientific and measurable truth. Then we went on to printed truth, which has now become digital. And the digital truth is not really fulfilling our expectations because it's not really clear what's true or not, whether it's news or whether it's commercial parts of our life. So what I feel we all really build is the ability to create a verifiable and deterministic world that's powered by cryptographic truth. So that's the basis on which we're working on this, and that's what we're really putting, I would say, into the system. We've provided the largest amount of cryptographic truth ever into a multitude of different blockchains and different applications. That cryptographic truth has given rise to DeFi as a very early use case of deterministic, verifiable, guaranteed financial products. Even in the early stages of DeFi, it's processed over $8.5 trillion through Chainlink Oracle networks, which means not only has the data and the cryptographic truth been placed into various chains, but it's been used to generate over $8.5 trillion in actual transactional value. So it's pretty clear at this point that cryptographic truth and a verifiable deterministic way of guaranteeing outcomes is quite valuable. We started providing cryptographic truth on only one topic with market prices. Then we moved on to proof of reserves, identity, random numbers for games, automation, now functions, and most recently cross-chain. The reason we did this is because you actually need all of these different aspects of cryptographic truth and deterministically guaranteed computation in order to realize a truly verifiable web and a truly verifiable, reliable, useful set of applications. The reason for this is that it's not really one problem, right? The first problem might have been, I need to make a blockchain, make a token, or some kind of on-chain record. And that problem has been largely solved by great teams and technologies like Ethereum. Then there are other problems, such as what controls that asset, what controls that token, what controls that contract. The first dimension of that problem is data. So if the data is manipulated, the contract is manipulated and basically useless. The second dimension of this problem is the computation. So you can inject correct data, but if the computations that control the contract are manipulated, then the contract is manipulated and becomes useless. Likewise with cross-chain. If the contract basically uses a bridge and connects to some other place through that bridge and puts its value in that bridge, even if the data is correct and the computations are correct and the bridge is not correct, the contract gets manipulated and becomes useless. So this isn't just about making blockchains. This is about making advanced applications like DeFi, GameFi, decentralized insurance, and really every other thing that could be turned into a deterministic, verifiable format because reliable computation and cryptographic truth was applied to it. So that's the fundamental set of problems we solve, is how do you inject reliable, deterministic, cryptographically guaranteed data, reliable, cryptographically guaranteed computation, and reliable now cross-chain connectivity between contracts and all the other resources that it needs. This problem being solved, I think, will result in a very robust Internet of Contracts, where there's a lot of very valuable applications that are all connected to each other and able to use each other in the same way that web applications are both connected to various external resources and connected to each other. And this is when we'll hit a kind of escape velocity on what people are able to build in our industry and the value that it's able to provide. When the applications can be built in more advanced ways, connected to each other, and combined into more and more advanced use cases, and for all of that to become a very seamless, efficient, and highly secure. The most recent problem that we've started working on is cross-chain. So on the data side, we are by far the leader in providing all types of data and proof of reserves and many other things. On the computational side, for high-value use cases that need real security, we're by far the leader in securing those. The final piece of the puzzle is really cross-chain, because you want to provide people access to data, compute, well, you want to provide developers access to data, compute, and value so that they can combine those three things into advanced applications. The cross-chain problem, similar to the data problem and to the off-chain decentralized computational problem, was previously unsolved. So before Oracle Networks appeared for the data side, that was an unsolved problem. And before Oracle Networks appeared for automation and trust-minimized off-chain compute, people were consistently manipulating that. So there's a consistent pattern of the decentralized Oracle network solving these difficult security problems and decentralization problems that can't be solved by a blockchain, but need to be solved in order for blockchains and smart contracts to reach not even their full potential, but half of their potential. So there's a few key properties of CCIP that I think people should keep in mind. The first one here on this diagram is the risk management network. So if you think about any other system that moves any kind of value, there's always a risk management system. If you look at PayPal or Visa or MasterCard or any of these systems that have anything to do with value, they always have a part of their system that's responsible for managing risk and for assessing the risk of how that value moves between different places. Amazingly enough, in the cross-chain world, this doesn't exist. So in the cross-chain world, there is no notion of risk management whatsoever, which is why you can have $600 million moved to a completely previously unused and unknown address without any kind of automated check or anything happening, which frankly, from the world of the web world, is a really ridiculous idea, frankly. So we've introduced risk management, and the risk management is very robust and configurable. So the way that the Chainlink CCIP system works is you have networks that are responsible for the transaction, and they are what is known in the infrastructure world as a thin pipe. So they are responsible for high transaction throughput at high speeds at large scale. And in there are some basic automated related security checks. Then you have the smart network, the kind of smart contract network called the risk management network, which is where you encode all the risk management conditions. And those conditions will change between the different bridges and their users and their counterparties, and also based on their appetite for risk. All of this, by the way, is done through multiple independent nodes running their own separate networks, whereas many other bridges are basically one or two nodes run by the same person who, when they lose their key, you have something like multi-chain happen. Or it's one network that fundamentally can't scale and so on. But we've made a way to make thousands of bridges that also have good risk management that people can configure to meet their requirements. And the better you are at risk management, basically the lower the cost will be at the higher speed. So the degree to which you can do risk management of transferring value, that's what determines the cost and the speed at which you can do those transactions. And this has just been consistently true for the past 70 years of people transferring value over the internet. And so I think we should learn from that and include it in how we do it in our industry. The second thing that's quite important is the ability to combine data and tokens. So as you can tell from our previous work, the Chainlink network for approximately 4 years has successfully processed $8.5 trillion worth of transactional value, actually more than that, and it's processed that through putting huge amounts of data on multiple chains. So it's really fundamentally the same problem with cross-chain, is instead of putting market data or proof of reserves data or random numbers or something else, now you're involved in transmitting and confirming and validating cross-chain data. And so the system that was built in a way where you can transfer the value of the token. That's great. You can transfer a message to instruct other contracts to do things, even if you don't move a token. So this means you can control contracts through CCIP from some other place. But the really powerful thing is when you can combine the token and the value with the instruction. And what this means is that you can stay in one place, like a wallet or your own chain, and then you can send value to other places with an instruction about what that value does. So you can basically say, take my token, send it to blockchain X, to smart contract Y, and trigger function Z. And that means that you don't need to go there. Because right now, the user experience of all these bridges is absolutely ridiculous. You have to take your asset out of your wallet. You have to put it in a different place, the bridge. You have to bridge it. Then you have to go to the other place where you bridged it. You have to get a wallet over there. You have to take it out of the bridge thing, put it in your wallet, and then maybe you can do what you want to do. So that's like, depending on how you count it, anywhere from 6 to 15 steps. This thing is one step. You basically say, I want my token to go over there and do this thing. Done. And you can do that from a wallet or from a chain or actually from your own Web2 backend. And this is the thing that's going to remove a lot of friction for both wallets, chains, and even Web2 systems to interact with the blockchain in an efficient, secure, and high throughput way. The other thing this also allows, by the way, is the ability for assets to stay updated as they move across chains, right? So you make an asset on chain A, bank chain A. It goes to bank chain B because they bought it, and then it gets put in custodian chain C. But the asset still needs to be updated, like with, the status of the gold or the status of the house or the status of whatever, or the identity or something else. Well, guess what? If you don't update the asset, the real world asset's not so good no more, right? It's not so useful because it's not connected to the real world. So you also have to keep it updated. The final thing that I think this will result in is a very easy way for banks to take trillions of dollars in value and transact with each other, and then to transact with public chains. This is maybe the final thing that I think CCIP will hopefully achieve, is the ability for banks to reliably connect to hundreds of chains. Initially, they will connect to the chains of the other banks, but then those banks will connect with public chain use cases. And eventually, the whole industry will just become one big place composed of banks and DeFi and a whole bunch of other people. So what CCIP does is it creates an abstraction layer for banks to easily utilize all chains, whether they're bank chains or public chains. This is what we're working on now with CCIP, working with some of the top banks in the world. What I'm seeing is that it's happening kind of regionally. A US bank wants to transact with another US bank, European bank with a European bank, an Asian bank with an Asian bank. Our goal is to first facilitate those transactions between those banks in their private bank chain world. Then, the next goal is to make sure that those bank chains with trillions of dollars can connect to public chains. And we've already made a lot of progress on that by getting various bank assets, their stable coins or whatever, to go into public chains, which I personally feel is where a lot of the future value of our industry will come from. Then I think we'll arrive at a world where you're hyper-connected, public chains, bank chains, DeFi, regulated DeFi, bank assets are all mixed into one big internet of contracts because they're all doing the fundamentally same thing. They're trying to create assets and financial products and financial systems while managing risk. And users will fundamentally combine them into more and more advanced applications. And all of that will be powered by reliable data, reliable compute, and reliable cross-chain connectivity that does have to happen between all the DeFi startups and all the banks. We're just kind of in a world now where the DeFi startups are in one world and the banks are in their own world, and there's kind of like this legal wall, but that legal wall is gradually being taken down on its own. And as that comes down, the amount of interaction between these two groups will only increase. This interaction, I think, will benefit not only our industry, but actually the whole global financial system, which will end up running on crypto. Like if you ever wondered how does the global financial system end up running on crypto things, this is how. It's because they can connect to all the other crypto things and get value from those things. And then those other crypto things are reliable because they have reliable data, reliable compute, and reliable connectivity. So this is the body of work we're involved in. It's creating this access for reliable data, access to reliable compute, and now access to reliable cross-chain value, so that developers can build advanced smart contract applications on both the DeFi public chain side and the bank side. And then eventually both of those places will just become one big place called the Internet of Contracts or Web3 or whatever we come up with calling it. But it doesn't really matter what it's called. What matters is that that's how the world's going to work, because it's reliable and hyper-connected. So thank you very much. Hope you have a good conference, and hopefully this is useful.